When we have a product of two functions and we need to integrate them, then the question is, how do we do it? It's very tricky. X times by cos x. There's no obvious substitution. There's no standard form that looks like that. But there may be some help to be had from differentiation, because for all we don't know how to integrate a product of two functions, one of the things we do know is how to differentiate it. So let's take y equals u times by v, where u and v are two functions of x. And let's differentiate it. So dy by dx is equal to the derivative of uv, which we do as u dv by dx plus v du by dx. Now I'm going to take this bit and rearrange it. I'm going to focus on this as the subject of my formula, the major interest, so to speak. So I'm going to take this bit away from both sides. So that's u dv by dx is equal to the derivative of u times by v with respect to x minus v du by dx. Now, this is still a product of two functions. So let's integrate it and see what happens. So we have the integral of u dv by dx with respect to x is equal to the integral of the derivative of uv with respect to x minus the integral of v du by dx with respect to x. Now, this is easy, this bit. We've differentiated it and we've integrated it. So we must get back to what we started with. So we have the integral of u dv by dx with respect to x is equal to uv minus the integral of v du by dx with respect to x. This is the formula which we call integration by parts. And we can see why it gets that name, because in essence we're integrating a part of the product at a time. So we take dv by dx and we integrate it and we put it there and we put it there. We take u, we put it there and we differentiate it here. And our hope is that starting from one product, u times dv by dx, we end up with an integral here of another product which is simpler, because we always have a choice. So let's go back to the original example that we started with. We asked ourselves the question, could we integrate x cos x with respect to x? Now remember, we've got a choice. We can take this to be u, or we can take this function to be u. Now let's just write down the formula again so we can see what happens. U dv by dx integrated with respect to x is equal to uv minus the integral of v du by dx integrated with respect to x. Now let's examine our choice. We could take cos x to be u. Now let's just track through what would happen. We'd have cos x there, we'd have cos x there, and when we differentiated it, the derivative of cos is minus sine. This we would take to be dv by dx. So when we integrate it to get v, we'd get x squared over 2, and we get x squared over 2. So if we think about it, here we'd have x squared over 2 times by minus sine x. That is no simpler. In fact, it's more difficult than this is. Let's change our choice round and let's take u to be x. du by dx is just 1. Let's take cos x to be dv by dx. So dv by dx is equal to cos x. And if we integrate that, v is equal to sine x. So let's just check again what's going to happen. This will be 1 here, and this will be sine x. So we'll have sine x times by 1, and we can integrate that. No problem, we can do that. So this is what our choice is going to look like. We're going to choose x to be u and cos x to be dv by dx. Okay, let's do this again on a clean piece of paper. So we've got the integral of x cos x dx. We're going to choose this to be u and this one to be dv by dx. Let's write down the formula so we can see what we're doing. This will be u v minus the integral of v du by dx with respect to x. U is x. Now v is the integral of cos x, which is just sine x, minus the integral of v, which we know is sine x, times by du by dx, which we know is 1. So this is x sine x minus the integral of sine x dx. And this bit stays the same. And the integral of sine is minus cos, which with that minus sign there gives us plus cos x plus c. And so we've achieved what we wanted to achieve. We've integrated this product. But notice how important this choice is. Okay, let's take a second example. Let's say we want to integrate x squared times by e to the 3x with respect to x. It's a product of two functions, so we can know that we're going to want to use our integration by parts formula. So now we've got to make our choice between u and dv by dx. Now we've already learnt that it probably makes sense to take this to be u, because when we differentiate it to put it here, it's going to be simpler. So this is going to go from x squared to 2x when it goes in there. That is simpler, therefore, than what we had here. So let's make that choice, and we're probably going to have to recognise we're going to have to do this second integral again by parts. So we'll choose this to be u, and we'll choose this one to be dv by dx. So equals u, which is x squared. Now we want v, so we need to integrate e to the 3x, which will be 1/3 e to the 3x, minus the integral of v is the same again, 1/3 of e to the 3x, and this time times by du by dx, times by 2x with respect to x. Tidy this bit at the front up, 1/3 x squared e to the 3x minus the integral of 2/3 x e to the 3x dx. And we can see that this integral is going in the right direction. This is simpler than the one we started off with. So we're going to do this again, and we're going to make similar choices. This is going to be u, and this is going to be dv by dx. So 1/3 x squared e to the 3x minus, now it's helpful here to put in a bracket so that we keep all of this together and we take it all away and not just little bits of it and forget exactly what it is we're doing. So we've made our choice that this here will be u, and we want uv, so that's 2/3 of x. Now this is now dv by dx, and we need to integrate it, so that's 1/3 e to the 3x minus the integral of 1/3 e to the 3x times by, and we want the derivative of 2/3 of x, which is just 2/3 dx, and close that bracket. Now let's tidy this up. 1/3 of x squared e to the 3x minus, and I'm going to keep the bracket there for the time being, 1/3 times 1/3 is 2/9 x e to the 3x minus the integral of 2/9, 1/3 times by 2/3, e to the 3x dx, and close the bracket. So I'm now in a position to finish this off. So I'll turn the page, write it down again, 1/3 of x squared e to the 3x minus, and then the bracket, 2/9 of x e to the 3x minus the integral of 2/9 e to the 3x dx, and close the bracket. So what we'll do is we'll remove this bracket first, 1/3 x squared e to the 3x minus 2/9 of x e to the 3x, and then minus minus gives us a plus, and that's why I advised putting in the bracket, so you keep all this together so that when it comes to doing the simplification we get the signs right. The integral of 2/9 of e to the 3x dx, and we just have this last integration to do to finish it off. 1/3 of x squared e to the 3x minus 2/9 of x e to the 3x, and then finally we integrate e to the 3x, that's 1/3 of e to the 3x, we have 2/9 here to multiply it by, so that's 2/27 of e to the 3x, and that's the last integral, so we want plus c for the constant of integration. So we've seen two examples now, one where we had to use integration by parts once, and a second one where we used integration by parts twice. Sometimes you may have to do it 3 times, but that would be a little unkind. But let's have a look at a somewhat different example. The integral of x times by the log of x. It's a product of two functions, x and log of x. But the choice here is important. Let's write down the formula that we've got for integration by parts and think it through. Our natural instinct would be to choose x to be u. So let's do that. So x is u, and the log function, the log of x, to be dv by dx. Okay, we know we're going to have to differentiate x. U equals x, so du by dx is 1. And we've got dv by dx, that's equal to the log of x, and we've got to get v out of it, so we've got to be able to integrate the log of x with respect to x equals what? Do we know what the integral of log of x is? Well, no, we don't. But we do know how to differentiate x, the log of x rather. We do know how to do that differentiation. If we were to change our minds and do u equals log of x, then du by dx would be 1 over x. So here, the choice is made by which of the functions we can actually integrate and differentiate. We can't integrate log of x, but we can differentiate it. And that means that our choice has to be u is log of x. So let's start this one off again. X log of x dx equals, our formula says this is uv minus the integral of v du by dx with respect to x. And we'll make the choice this time that this is dv by dx and this is u. So, u, that's just log of x, times by v. We have to integrate x. Well, we can do that, that's straightforward, x squared over 2. Minus the integral of v again, x squared over 2, times by the derivative of this, which we can do. It's 1 over x dx. So, let's put this in front of the log x. That's x squared log of x minus, we can do a little bit of simplification here. We can divide by x and by x, and that would leave us with x over 2 to be integrated with respect to x. So now we can complete that, and the integral of x is x squared over 2. It's already over 2, so that would be x squared over 4, plus, again, our constant of integration. So just to hammer home that point, here our choice was governed by what we could actually integrate and what we could actually differentiate. Let's take that a stage further. You remember that when we looked at this, one of the things that we couldn't do was we couldn't integrate log x when we first looked at it. That's what prompted us to change our choice, so to speak, to move from one to the other. So what if we said, well, come on, what is the integral of log x? How can we do it? Well, first, let's make it into a product. And let's make it into a product of two functions by saying it's 1 times log x. Then make the same choices as before. The log x becomes u, but this 1 is what becomes dv by dx, because we can integrate 1. So writing down our formula again, this is uv minus the integral of v du by dx with respect to x equals u, that's the log of x, times by v. Now dv by dx is 1, so I have to integrate 1, that's just x, minus the integral of v, so that's x, times by du by dx, the derivative of log x, that's just 1 over x, equals x times by the log of x minus the integral of, well, x times 1 over x is just 1, and we can do that integration. The integral of 1 is just x plus a constant of integration c. And so we've integrated log x. Now that's not one to remember, but it is one to remember how to work it out, because it works with other functions that one comes across that you don't know how to integrate. You turn them into a product like this, and away we go. I want to take one final example. The integral of e to the x sine of x. Now, we look at this and we say, well, we've got a choice to make. One of them's got to be u, one of them's got to be dv by dx. But which? But one of the things that we know from the examples that we've done is that if it was x times e to the x, we choose the x to be u so we could differentiate it, because the e to the x doesn't get any simpler. But we do the same with the trig function, because that doesn't get any simpler. So it doesn't look good. We don't seem able to make a choice between these two, because neither of these two functions, when we differentiate them, get any simpler. But we've still got to make a choice. So the choice that I'm going to make really doesn't matter, but I'm going to do it anyway. So I'm going to call this u, e to the x, and I'm going to call the sine x dv by dx. Equals. Let's write down the formula. uv minus the integral of v du by dx with respect to x. U is e to the x. It stays the same. V is got by integrating sine, and the integral of sine is minus cos x. Minus the integral of minus cos of x times by the derivative of u, which is just e to the x dx. Let me just tidy that up a bit. Lots of minus signs knocking around. So we've minus cos x times by e to the x plus the integral of e to the x cos x dx. And back to something that looks like this again. Let me make the same choices then. Let me call this u. Let me call this dv by dx. So this is minus cos x times by e to the x plus, and a bracket, uv, u is e to the x, v, well, v is now the integral of cos x, and the integral of cos x is sine x, minus the integral of v, which is just sine x, times du by dx, and du by dx is e to the x dx, and close the bracket. So we've got this term at the front, which is minus e to the x cos x plus e to the x sine x minus e to the x sine x dx. But this is exactly what I started out with. Exactly what I started out with. It's the integral I began with. So if it's the integral I began with, let's call it I. Let's say I equals this integral. So what I've got here is a sort of equation for I. Minus I. And if I add I to both sides, I'll end up with 2I equals minus e to the x cos x plus e to the x sine x. And now I can take a half of each side, divide both sides by 2, 1/2 of minus e to the x cos x plus e to the x sine x. And so I found my integral. Rather remarkably, I found it without actually, apparently, integrating it at all. It came out of solving an equation. So, that concludes integration by parts. You need to remember the formula. Let's just write that down to finish with that if we are integrating u dv by dx, the result we have is u v minus the integral of v du by dx with respect to x. And I need to put that in there as well. We always have a choice which of the two functions we're multiplying together to be u and which to be dv by dx. Our first choice is usually governed by if we differentiate the u, will it make it simpler? Will it make this second integral simpler? If that doesn't work, it's governed by whether we can actually integrate or differentiate certain of the functions, and sometimes we need to repeat it so that we can solve an equation to get the integral. But this needs to be remembered, the formula for integration by parts.